So case 4 of integrating rational fractions is when the denominator contains irreducible quadratic factors and some are repeated. So these are the corresponding partial fractions for the repeated quadratic factor. So similar to case number 2 for repeated linear factors. So we start off with raising the quadratic factor to a power of 1, then followed by a power of 2 until the last value of n. Okay, for example, if the quadratic factor is raised to the power of 3, then you stop to 3 for the third, okay, partial fraction. Similar to case 3, you need to multiply the first constant with the derivative of the irreducible quadratic factor, then add a constant term. And similar to this first numerator, then the second partial fraction has this numerator and the other partial fractions. Okay, where A, B, C, D, K, and L are constants to be determined. And again, 2ax plus b is the derivative of the irreducible quadratic factor. So we have here an example. So this is raised to the power of 5. So the degree of the numerator is 5. If you square this, it's 4. Okay, fourth degree. And there's an x squared. So 4 times 4 plus 2. So that's 6. So this is a 6-degree polynomial. So this is a proper fraction. So no need to perform long division to get the quotient and the remainder. We can already proceed to the formation of the corresponding partial fractions. So we have here another quadratic factor, but this is factorable because it's a difference of two squares. So it's a product of x minus 2 and x plus 2, right? It's a perfect, that's again difference of two squares. So we have the first fraction, partial fraction. Okay, it's a over x minus 2 followed by the second partial fraction with the second factor for x squared minus 4, which is x plus 2. Ay. And then for the repeated quadratic factor, x squared plus 1 is not reducible. It's not factorable. If you have a sum of two squares, it's not factorable. You can only factor it out if it's a difference of two squares. So it's a reducible factor. So its derivative, no derivative of x squared plus 1 is 2x plus 0 or just 2x. So meaning constant times the derivative of x squared plus 1 plus constant plus d. And then all over the quadratic factor raised to the power of 1. So since it's being raised to the power of 2, so we need to add one more partial fraction. This time we use e and then 2x and then plus f. Okay. And this quadratic factor must be raised to a power of 2. So we need to stop here. So we have 4 partial fractions. So we need to solve for 6 constants A, B, C, D, E, and F. So multiplying this entire fraction in the integrand with the denominator. Okay, so it's equal to the numerator. So there are no missing terms from x raised by 5 down to the constant term. So equate it to a over x minus 2 times x squared minus 4 and the square of x squared plus 1. So that means we have x plus 2 and x squared plus 1 quantity raised by 2 left. And then for the second term, so we'll remove x plus 2. So we have x minus 2 and x squared plus 1 quantity raised to the power of 2. Okay, plus the third term, c times 2x plus d. You multiply it with, so minus 1 x squared plus 1. So that's x squared minus 4. So do not factor this, okay, out into x minus 2 and x plus 1 because we'll combine no all the factors. So just write it as x squared minus 4 and the remaining x squared plus 1. And then plus e times 2x, okay, plus f multiplied by x squared minus 4. Okay. Next is to get rid of the grouping symbols and then later equate the coefficients. So we need 6 equations here because we have 6 unknowns. So a times x squared plus 1 para there's no need to rewrite everything. Squared is x raised to 4, okay, plus 2x squared plus 1, right? And if you multiply it with x plus 2, each term must be multiplied to x plus 2. So that means x squared 5 plus 2 x raised to power 4. Then proceed to 2x squared times x plus 2. So that's plus 2x cubed plus 4x squared. Okay, then 1 times x plus 2. That's x plus 2. Okay, then for x minus 2, do the same thing. So again, this is equal to, no, the square of x squared plus 1 is equal to x raised to 4 plus 2x plus 1. So x raised to 4 times x minus 2, that's x raised to 5 minus 2x raised to 4. Then proceed to 2x squared times x minus 2. So that's 2x cubed minus 4x squared. And then 1 times x minus 2, that's x minus 2. Then for the third term, so the product of x squared minus 4 and x squared plus 1. Okay, so I'll just write the product here so that there's no need to rewrite the third term on the next step of the equation, of the solution rather. So we have x to the power of 4. Okay, for the middle terms, we have negative 4x squared plus x squared. So that's negative 3x squared. And then for the last term, it's minus 4. I'm using the FOIL method here. So if we're going to multiply this trinomial with 2x and c, so it would result to 2cx raised to the power 5 minus, okay, all right. So let's put the c here instead of multiplying it to each of the terms so that it would be easier later to look at the coefficients. Okay, so just multiply 2x and x to the power of 4 minus 3x squared minus 4. So that's 2x raised to the power of 5 minus 2x times 3x squared. So that's 6x cubed. And then 2x times 4. So minus 8x. Okay, then plus d times x raised to the power of 4 minus 3x squared minus 4. And then for the last one, x squared minus 4 times 2x for e. So meaning that's 2x cubed minus 8x and then plus f times x squared minus 4. That's kind of long. Okay, so we equate now the coefficients. So starting off with what's the highest power here? We don't have a 6. It's only 5. So starting off with x raised to the power of 5. So it has a negative 3 coefficient on the left side. So on the right side. So you can put a dot after writing the corresponding coefficient so that we will not be confused with so many terms here. So followed by this multiplied to b. So that's plus b. And then look for other terms with x raised to 5. So this one, so that's 2c. So plus 2c. And then no more x to the power of 5 terms left. So next is for x raised to the power of 4. So on the left side of the equation, it's negative 6. This one, negative 6 is equal to here, it's 2a, b, negative 2b. And then we have this one. So d and no other x to the power of 4. So plus d, okay, plus d. Second equation. Next, for the x cubed terms, so we have here negative 2 is equal to 2a. Don't forget the a. Then we have this one. So that's plus 2b. This minus 6c. And then we have this one, meaning 2e. Okay, so plus 2e. Next, x terms, or x squared terms rather. So negative 4 on the left side. This. Then 4a. So for this one, that's minus 4b. Then minus 3d. Then plus f. Followed by, so let me just rewrite. X terms on the left side, we have negative 19. We have a, And then we have here plus B. And then we have minus 8C. And we have the constant terms. Okay, negative 6 on the left side. We have 2A on the right side. And minus 2B. Then, okay, minus 4F. Okay, so there's still a minus 4D before the minus 4F. Minus 4D minus 4F. Okay, so that's why it's very important to put a mark, okay, so that we'll know which of the terms we missed. So like for this one, there's no minus 8EX. So you need to include that for the X term. So minus 8E. So we have 6 equations, okay, with 6 unknowns. So how the Carabao? How do we solve for the 6 unknowns? So we need to reduce, okay, the number of unknowns. So we cannot solve for just one unknown here. Okay, so we can start off with maybe eliminating, okay, eliminating A and B using 1 and 5. Okay, so that we can have relationship of C and E. Okay, or 2A minus 2B. We'll have the relationship of D and F. Okay, or we can multiply equation 5 with 2 so that this becomes, sorry, this becomes 2A plus 2B. So we can have a relationship of C and E. Yes, let's start off with the ones with lesser number of terms. So we can use again these two. What did I mention first? 1 and 5 equations, 1 and 5, so that you can eliminate A and B. So right, equations 1 and 5. Okay, to eliminate A and B, so 1 will perform 1 minus 5. Okay, 1 minus 5. So let me eliminate 1 and 5. So replacing it with 1 minus 5. Equation 1 minus 5. So meaning, okay, so you can have it written in, and that's not equation 1, sorry. So copying equation 1, that's negative 3 is equal to A plus B plus 2C, and you perform subtraction for negative 6, or rather not negative 6, that's negative 19. No, this equation equals A plus B minus 8C minus 8E. Okay, so again, perform subtraction, so by elimination method, so that we can eliminate A and B. So negative 3 minus negative 19, that's 16. Okay. A minus A is 0. B minus B is 0. 2C minus negative 8C, that's 10C. And then 0e for the equation 1 minus negative 8e. So that's plus 8e, right? If you want to apply addition instead of subtraction, so just look for suitable k equations. Okay, so the number of unknowns is now being reduced to 2 from A, B, C, and E from 4. Okay, so let this be equation 7. So we'll use that later. So we need to form mm, look for terms with also C and E so that we can equate or we can eliminate C and E, and we can use equation 3. Okay, equation 3 and equation 5. Okay, but as much as possible, no, so use the other equations left. Okay, so do not repeat equations yet. Okay, so let's try reducing equations 2 and 6 because they have common 2a minus 2b and with a d. So from a, b, d, and f, it will now be reduced to just d and f. Okay, so we can perform subtraction for 2 and 6. So we have negative 6 equals 2a minus 2b plus d, and then minus the constant equation. Negative 6 equals 2a minus 2b minus 4d minus 4f. So negative 6 minus negative 6, that's 0. 2a minus 2a, which is also 0. So we have negative 2b minus negative 2b is also 0. So d minus negative 4d, that's 5d. And then 0f minus negative 4f, that's plus 4f. So let this be equation number 8. Okay. So we can have relationships of C, E, D, and F. C and E, and then D and F. So, how about relating C, E, D, and F using equations 3 and 4? Okay, but we need to eliminate A and B. So if we are going to eliminate A and B, the coefficients must be equal. So we need to multiply first equation 3 by 2. Okay, equation 3, multiply it by 2. So it's negative 2 equals 2a plus 2b minus 6c plus 2e. Okay, times 2. So times 2. So that becomes negative 4 equals 4a, right, plus 4b, right, minus 12c plus 4e. Hmm, okay, and then we can subtract here. I don't need to rewrite because it's too long. Subtract equation 4. Mm, for a moment. Set equation 4. Okay, equation 3. And equation 4. So we can eliminate lang the one of the two terms and not both terms because it's a plus here and a minus here. Okay, so if we're going to subtract equation 4. So we'll end up with B, um, C, D, E, and F. Okay. So we cannot eliminate B here. So it's a sort of a trial, no, and error. So we can instead, let's see, okay, we can use 1 and 3 so that we can eliminate A and B, and then we'll have another equation relating C and E. Okay, sorry, so erase, erase. So I thought this has the same operation, no, plus and plus or minus and minus. They are different. Okay, so we cannot eliminate both A and B terms. Okay, so much as possible, eliminate many terms so that the number of unknowns will be reduced by higher number of unknowns. Okay, so 1 and 3, to have another equation relating C and E. Okay, 1 minus 3, but we need to multiply 1 first with 2 so that it becomes 2A, no, plus 2B. Sorry. So 1 times 2. I'll just put na lang, no, the result of multiplying 2 and equation 1. So negative 3 times 2, that's negative 6. So this becomes 2A plus 2B plus 4C is equal to 2A plus 2B plus 4C. And then we subtract equation 3. Okay, equation 3 is this one. Negative 2 equals 2A plus 2B. And then minus 6C plus 2E. So we have another equation eliminating A and B. So negative 6 minus negative 2, that's negative 4. Okay, equal to 4C, eliminating 2A and 2B, no? So 4C minus negative 6C, that's 10C. And then 0E minus 2E, so that's negative 2E. So let this be equation number 9. So as you can see, okay, equation 7 and 9, they have something in common. No? They have 10C. So we can eliminate 10C, okay, by subtracting the 2. 7 minus 8, or you can also do 8 minus 7. Okay, so 16 equals 10C plus 8E, okay, minus. So I'm putting parentheses so that you will take note that it's subtraction. Okay, so just okay, just solve for the difference, no, mentally. 16 minus negative 4, that's positive 20, or 16 plus 4, no? So positive 20, 10C minus 10C is 0, and 8E minus negative 2E, that's positive 10. 8 plus 2, no? So that's positive 10E. So we can now have the value of E, which is 2. So yay, one unknown, one constant, no, solved. So from that value of E, we can now solve for C by using either equation 7 or equation 9. Yes, I will use equation 9. Or the one with, so they are both 10C. So it's either of the two. No? So let's just say from 9, okay, solve for C. So negative 4 equals 10C minus 2 times E is 2. So negative 4 equals 10C minus 4. So negative 4 plus 4, that's 0 over 10, 0. So C is 0. All right. And then 2 constants down. So if C is 0 and E is, what do you call this? 2, C and E. Okay. Use the equation 1 with C and E. Okay, this C and E. So all other terms contain A and B. So let's have this equation 8. So find a way that we can eliminate either D or F. So we need to make another equation. Okay, so we used 2 and 6 earlier to eliminate A and B, and D and F now will be left. So look for common equations with D and F. Okay, so we can repeat 2 and maybe we can use 4. Okay, here, no, 2 and 4. 2 and 4 because, okay, so it's minus and minus. So we can eliminate A and B here by multiplying equation 2 first with 2. So that becomes 4A minus 4B. So eliminating A and B. So equation 2 times 2. So that would be negative 6 times 2 or negative 12. Okay. 2A is 4A. Okay, minus 2B times 2. So that's 4B. And then okay, 2 times D. So that's 2D. Then 4 is, okay, so you subtract equation 4 to eliminate 4A and 4B. So let's just copy it. Negative 4 equals 4A minus 4B minus 3D plus F. Okay, so perform subtraction. So negative 12 minus negative 4 is negative 12 plus 4 is negative 8. 4A minus 4A. 0. 4B minus 4B. That's also 0. 2D minus negative 3D, or that's 2 minus negative 3. Or that's 2 plus 3. So 5D and 0 minus F. So negative F or minus F. So let this be equation number 10. So we have 8 and 10 with same unknowns. So we can perform subtraction again using these two. Okay, 0 equals 5D plus 4F. Okay, and then minus negative 8 equals 5D minus F. So that's 0 minus negative 8, or that's positive 8 equals 5D minus 5D is 0. And then 4F minus negative F, that's 5F. So therefore, F is 8 over 5. Okay. So we now have the third. unknown solved. And we'll use equation 10 to solve for D. So from equation 10, solve, solve for D. So it's negative 8 equals 5. D minus F, so minus 8 over 5. So negative 8 plus 8 over 5, or just multiply everything with 5. So it's negative 40 equals 25D minus 8. Or that's negative 40 plus 8 is negative 32 equals 25D. Okay, so D is negative 32 over 25. So we have the fourth unknown. So we have na lang A and B left. So look for an equation with lesser number of um, terms. Okay. So especially if there's a zero value, like in C, it's 0. Okay, so here, okay, so from equation 1, make another equation with only A and B. So from equation 1, so plug in the value of C. The value of C again is 0. Okay, so meaning negative 3 equals A plus B. All right. So we have another equation. Let this be equation number 11. So we need another equation containing A and B so that we can solve for either A or B first. So maybe we can use this. Okay, we already have the value of D, okay, which is negative 32 over 25. So from equation 2. Okay, from 2. Okay, so negative 6 equals 2A minus 2B. Oh, wait, no, no, plus. Again, it was 32, negative 32 over 25. So negative 32 over 25. So just multiply everything with 25. Okay. Um, that would be 25 times 6. So that's negative 150 equals 25 times 2, that's 50. So 50A, okay, minus 50B, and then minus 32. So negative 150 plus 32, that's negative 118. Okay, equals 50A minus 50B. So although it's, what do you call this? It has two unknowns, no, but although it's plus and minus here, we can transform this into putting A, for example, on one side. So it's going to be equal to negative 3 minus B. Okay, so we'll replace A here in this equation, okay, with no something from equation 11. Instead of writing A, okay, we write negative 3 minus B and then minus 50B. Okay, so negative 118 is equal to negative 150 minus 50B minus 50B. And that's negative 118 plus 150, so that's 32. Minus negative 150, if you put it on the left side, no, it's 32. It's equal to negative 100B. Negative 50 minus 50, that's negative 100B. So meaning B therefore is negative 32 over 100, or that's 8 over 25. Both are divisible by 4, no? So 8 over 25. So we now have the value for B. So what is left now is just A na lang, no? So from this, okay, so from 11 also solve for A. So A is negative 3 minus B, so negative 8 over 25. So that would be equal to negative 3 plus 8 over 25. Or that's negative 75, no? Plus 8 over 25. Negative 3 times 25 is negative 75. Plus 20, plus 8 all over 25, or that's negative 75. No, minus 8 is 67 over 25. So we have now A, B, C, and D, E, and F. So we can now proceed to integration. Whew. So let's copy na lang this part here. Wait, sorry. Or best siguro if screenshot na lang. So let's put it here. Okay, so this is now equal to A is negative 67 over 25. Negative 67 over 25. Okay, over x minus 2. Okay. So let's zoom that out. Wait. Then erase it. Okay. So, negative 67 over 25. Okay, over x minus 2. Okay, dx. So, ito na lang i-write separately. And then B is negative 8 over 25. Negative 8 over 25. And then all over x plus 2. So no problem with the first two terms. Can easily integrate that. Plus, okay, C is 0. So D is negative 32 over 25. So it boils down to negative 32 over 25 over x squared plus 1. So this is in the form u squared plus a squared. So meaning we'll use tangent later. U is x and a is 1. And then plus, okay, for e times 2x. So e is 2 from here. So that's 2 times 2x. So that's 4x. Now, similar to case number 3, okay, we can separate no the next term. Let's just write na lang sa 8 over 5. So plus k8 over 5 and then all over x squared plus 1. Okay, wherein you need to integrate. So for the first term, let u be equal to x minus 2. Okay, so du is just dx. So meaning we can have it in the form du over u. So just put the constant here and then ln of x minus 2. Okay, for the second term, just similar to the first term, so that's negative 8 over 25 ln of x plus 2. Oh, no, x plus 2. And then x squared plus 1, this is in the form u squared, as mentioned earlier, u squared plus a squared. So we'll use arctangent of u over a, 1 over a times arctangent of u over a, and a is just equal to 1. So that's minus 32 over 25 arctangent u over a. Okay, u is x and a is 1. So basically it's just arctangent of u, right? And for the next term, okay, so we have 4x plus 8 over 5. And we have a square of a sum of two squares. Okay, so we can separate it into two parts. So one is you have 4x over x squared plus 1 quantity raised to power 2 and nako, 8 over 5 over x squared plus 1 quantity raised to the power of 2, okay, dx. So for this one, okay, we can let u be equal to x squared plus 1, and we can write it as u squared as long as we have the du. So it's 2x dx, 2x dx. Okay, so we need a neutralizing factor of 1/2 because we can put 4, okay, outside. So we need 2x dx. So we need a 1/2 for the neutralizing factor. Or just write it as 2 times 2x. You can also do that. Or that's 4 times 1/2. Basically, it's just the same thing. No, the result is 2 du. Okay. And for the last one, the last term, okay, so we have to apply trigonometric substitution here. Okay, so if a squared plus u squared is present, recall trigonometric substitution. Okay, you need to let um u be equal to a tangent of theta. Okay, so u here is x and a is 1. Okay, tangent of theta. So tangent of theta is basically equal to x over 1. So if we're going to draw no, the triangle, so tangent of theta meaning opposite over adjacent. Opposite side is x, adjacent side is 1. So the hypotenuse is square root of x squared, no? Plus 1. Okay. So we can use that later. So we need also to solve for dx so that we can replace the dx in the given integrand rather. So dx is secant squared. No, derivative of tangent theta is secant squared theta d theta. Okay, and to form the x squared plus 1 quantity squared, so from this triangle, So square root of x squared plus 1, pair it with a constant. Okay, x squared plus 1. So pair it with another side, which should be a constant. So meaning that's hypotenuse over, no, hypotenuse over adjacent side. Or that would be equal to second, right? So second theta. So meaning if we're going to square the entire equation, it's x squared plus 1 equals second theta. Okay, so we can use that to transform this into integrable form. So this will now be equal to, so let me just write the transformation here. So just put the constant outside. So dx is second, ay naku, second squared theta d theta, no? And then over second theta for x squared plus 1 here below, second theta. So you need to square it. Basically, it's just second squared theta over second squared theta. That's basically equal to d theta. Okay, so this is equal to 8/5 times the integral of d theta. Or that's 8/5 theta. And from this equation, tangent is equal to x. So meaning theta is arctangent of x. So this is equal to 8/5 arctangent, no, of x. So just plus c, of course. Okay, so we'll put that here. So the final answer would be, so negative 67 over 25 ln of x minus 2. Okay, minus 8 over 25 ln of x plus 2. And then minus 32 over 25. Okay, arctangent of u, which is, u here is x. And then plus 4, no, times 1/2. So that's integral. This is transformed into integral of 2 k du over u squared. Or that's 2 u raised to negative 2. So the integral would be 2 u raised to negative 1 over negative 1. So basically that's negative 2 u raised to the power of negative 1. Or that's minus 2 over x. Okay, so we'll have this as 2 over x minus 2 over x. Okay. Hi, it's spinning. Hello. Okay. And for the last two terms, or last term na lang di ay. Um, plus 8 over 5, no, arctangent of theta. 8 over 5 arctangent of theta, arctangent of x, not theta, arctangent of x, which is basically similar ang terms to negative 33 over 25 plus 8 over 25 or 8 over 5. Okay, this is actually, equal to 32, not 32, times 5, 40 over 25. Na, di na magi. 40 over 25. Okay, this is going to 40 over 25. You combine it with this one, negative 32 over 25. So that's 8 over 25. So negative 67. Okay. So, give up na gyud ang pen. Hindi na nimo agi. So, minus 8 over 25 ln of x plus 2. And then plus, no, 8 over 25 arctangent of x plus c. Okay. And the minus 2x, 2 over x rather. Minus 2 over x plus c. Ay, naku. Okay, arctangent x. Minus 2 over x and then plus c. So one way to check if your answer is already correct is by combining, no, the partial fraction. See if it's really equal to the given fraction before you integrate. Or if you have the time, you can do that. If you don't have the time, then just make sure that the steps are correct. So that's case 4, no, of integrating rational fractions.